All right. Somehow OBS has broken everything. That's okay. All right. Welcome to Evidence-Based Audio Engineering number 179. And this is I Am Being Impeded. And mostly I'm being impeded because we just don't have the kind of sources we used to have for learning and, places you could actually go to learn about stuff, test things, get like actual science-based subject matter. Wow, this room is ringing like crazy right now. I don't know why. Hold on, sorry. There can't be an electronic problem. Let me just make sure there's no headphones going. Yeah, this room is ringing and ringing hard right now, and I don't know why. I foamed the crap out of it. Anyways, wow. Yeah, sorry. I'm really ringing. Why am I ringing? Okay, let's hope I'm done ringing. So yeah, that's a big problem nowadays. Is where do you turn for information? We've done plenty of shows talking about what Google brings you to. Maybe mostly commercials or just crappy advertisements or clickbait sites. And nowadays, you guys know when you go to look for information, you get these sites where it gives you first they give you a couple paragraphs on why you're even talking about the thing. It's like some school project, Upwork or whatever. It's just clickbait, and it's hard. Even the bike stuff, if I didn't have such a deep ties with the BMX community, I wouldn't know what the hell to buy anymore for bikes and things. And for the dirt jumpers that I'm doing now, I'm not finding any good source of information. And it's the same thing. I'm going through camera hell right now. I'm trying to get better camera stuff going, rather than just these little webcams and things. I gotta, I've been trying to do a lot of top-down technical work on, soldering and whatever. And having a lot of trouble. We still got that 29-minute limit. Okay, listen, Europeans. Actually, it's probably not even your fault. It's you camera manufacturers. I don't care what the European Union camera video guys are doing, that there's some kind of tax on a video camera or whatever. This is America. When you sell it here, we'll pay the tax. I don't care. Just take away that stupid 29-minute limit. Get out of there. I know some of these cameras aren't doing that now, but really, I don't know. I don't know what the hell I'm doing. I'm trying to use these CamLink HDMI inputs and the stuff. Like if you saw last week's show, just complete epic fail. So I've been going through camera hell this week. I'm just using this webcam. It's working. I did a nice video the other day with the camera going straight from the top. I'm probably going to end up using my spare old phone for one of them, and who knows. But anyway, it's hard to find information on these cameras, So it's really, we live in an age when we have tons of information. It's just impossible to get through now. And, we talk about signal to noise ratio, and, my company, we make noise gates, right? Because we're trying to discriminate between the sound we want and the sound we don't want. And somebody's got to cut through the search engine noise, because right now it's just worthless. You just end up with spam. So anyways, first thing here, want to look at Safe Space had a best studio gear. I want to see if there's anything on here that we even care about, right? The 10 best Thunderbolt and USB audio interfaces in 2022. Guaranteed they're going to put Universal Audio on there, and probably not for a good. Yep, Universal Audio Apollo. How would I know it was going to be on there? That's just amazing, huh? Apogee. Well, yeah. Some of these companies have a very long history of actually making stuff that works well. UA and Apogee aren't them. Yeah, I don't know how many abandonwares I've seen by Apogee. Here's RME Babyface Pro. Well, good. So you got a good idea there. Audient just came out with that Evo line. I wonder what that's like. It looked like a really good deal. Focusrite Claret Plus 4P. Are they even making this now? A lot of these companies had to cut lines because of the chip shortage. Yeah, this just looks like an advertisement. I don't know what I'm looking at. That's 10 best microphones under 300 for recording vocals in 2022. I am interested in this. Why are they the 10 best? We asked the gearspace.com hive mind. So is this come from a poll? 2020. Hey, look at that. Number one mic. Audio Technica 2020. Okay. So maybe I have to take a better look at this stuff because, man, this works awesome. You saw Vern Grainer, who was on this show, the amazing things he does with this mic. Orm Audio 47 Junior, isn't that what I have? I got 2 of these, I think. I haven't really used them much yet. I want to. I bought the black ones from Guitar Center. I don't know what I'm looking at. SC Electronics, SC. Oh, are they still around? These Lewitts, man, they look like 414s. Everybody's loving them. I'd like to try one, actually. I know Tommy got some, too. Antelope. No, I'm not buying anything from Antelope. You're going to sing into that? Try. RE320. T1, man. But that's funny that the 2020's up there. All right, let's. I'm not going to torture you guys too long with this. 10 pieces of gear to improve your podcasting and streaming audio quality. All right. I see a Samson USB mic on there. Really? You're going to use this mic for podcasting? Okay. SM7, of course, they're going to say that. Of course, I got an RE20 right here, so I can't say nothing. Army's Babyface Pro. I don't know, man. Zoom H4n. I don't know how. Are you really streaming with that? I don't think so. Rodecaster Pro. That looks handy. I don't think I really want one of these, but I should actually look into this. Let's look at what this thing actually does. Okay. So, for somebody like me who uses OBS and I have a lot of troubles of getting in and out of, the problem everybody has, moving audio between apps in the computer, getting out to your streaming software, like, what would I do? I'd come out my RME into that thing and then out that thing back into some. I'm not sure. So let's look at what this is, because I think this is just a mixer. I don't think it's got any internal stuff to move things around. Let's see. All right, well, that's absolute garbage of a description. Let's take a look. Rodecaster Pro. Oh, wait, there's a Pro 2, so seems this is old. 4 mic preamps, 8 faders, 8 programmable pads, USB to host, Bluetooth, Mac PC. I don't think this is going to do anything for somebody like me who's already using OBS. Well, looks cool. $700. I don't know. I buy the baby face. Some headphones, some little speakers, reflection filter, not bad. That would, if that was that ring, that would probably help. Alright, well, is there anything else interesting on this list? Virtual instruments, top selling synths, best keyboard synth. See, I always wonder who this page really is for. This is kind of telling it, huh? 10 most popular compressor plugins. I don't care. 10 of the best audio repair software plugins. This has come a long way lately. Then there's some cheaper ones out right now. Acusonus Era Bundle. I'm not sure what that is. This Acon Digital stuff, I was tripping out that, man, these guys had made some like free plugins that were pretty cool, but they made I tested one of these fixers. Antares, stuff is too sketchy. Cedar Audio is still around. Isotope, of course. RX9. Wasn't RX7 before? I guess it's 2 more better now. Soothe. Waves Restoration Bundle. Interesting. Okay. So what else do we got here? I think that was it on this list. 10 most popular DAWs. Do you guys even care? I don't think so. Yeah, this looks like AIM. All right. So here's the new product alert. Let's see if we see anything fun in here. Still talking about the crazy headphone thing from Steven Slate, $500 one, whatever. Mixbus 32C version 8.1. Nice. Native to M1 Apple stuff. Air Windows making a new amp sim. Nice. That's kind of cool. Audio Thing Fog Convolver. I think that was around for a while. active subwoofer. What does that mean? This isn't like, didn't they have like active bass traps for a while? JMP. Oh, see, I saw this. So this has looked interesting. So somebody made the even though wasn't it Scuffham Amps that actually was the developer of the actual JMP one? They got plugins, but these guys made the actual JMP one looking thing. Of course, they changed a little bit. I really wanted JMP one so bad back in the day. It was like a Marshall. It was one of the earliest MIDI preamps, and it was Marshall's one. It was pretty cool. But yeah, I couldn't afford anything like that. I actually, no, you know what? I saved up my money. I was going to buy either this or an MP2. I ended up buying an MP2, and I loved that, but I had to trade it for some wheels. I had a kind of crazy life then. But that's cool that there's a JMP one. We'll see how good it is. Let's give it a test next time. This guy named his software product Vegas Audio. That's, I don't know, dude. That's kind of lame. Wow. I really wouldn't have called it that, but maybe they don't know. I mean, like, okay. So if you weren't around for too long, Vegas was one of the earliest DAWs. It was actually my favorite back in the day, and kind of what Bass Reaper on. So, complete SSL subscription. Neural DSP releases yet another one of these partial plugins. All right, I'm sounding too negative. Let's go on here. So one of the things I want to talk about is speakers. I ordered one of the Celestion FRFR speakers. It was the F12 X200. It's like a 200 watt full range. It's got a tweeter in it, and oh man, that was a funny argument at a forum. The guy insisted there was no tweeter. There's a tweeter in it, okay? And you could put it in your regular guitar amp and or a purpose-built cabinet. And if you look at their cabinet that they meant for you to have, 12x200 cabinet, Celestion spec'd out something. And believe it or not, as much as I know about audio, I don't know much about speakers, really. And so Celestion had this one, and it had a port in it and a closed back. And recently, I think we talked about it on this show. Jim Lill did a video showing what actually made difference to the cabinet sound. I don't think he did ports though, and I never really understood what these ports were for. I heard people tell me that they make an extra octave of bass or whatever. So, and if you look at Celestion's one, take a look. They actually got a PDF that you can build. There's actually a guy on eBay that builds these and sells them, and they look really nice. So, tell you exactly how to build this the speaker cabinet here. And so I might end up porting one of the guitar cabinets or something. I just stuck it in a guitar cabinet, and it's sounding amazing. I'll just absolutely love it. But let's see. Show you. Let me check on. I got a band in right now, making sure everything's cool. Where is? Okay. Sorry. So these guys are showing a port, and like the length of the port seems to matter, the diameter of the port seems to matter. They said port baffle hole diameter to be determined from OD of pipe. So I think they're just saying, it has to be, you got to have the inside diameter a certain size, and then you're gonna have to figure out how much to cut out of the wood, whatever. So it sounds like this is critical, and so I don't understand. So I was looking in Wikipedia. I know, not the best place, right? But when I did the ported thing, it went to bass reflex, and so I'll read you what Wikipedia says. So, bass reflex system, also known as a ported vented box or reflex port, is a type of loudspeaker enclosure that uses a port or vent cut into the cabinet and a section of tubing or pipe affixed to the port. This port enables the sound from the rear side of the diaphragm to increase the efficiency of the system at low frequencies as compared to a typical sealed or closed box loudspeaker or an infinite baffle mounting. Okay, so wait a second. So this means that it's the back of the... oh, you can't see my fingers. What am I doing? It's the back of the enclosure. The speaker comes out the back, and then that... Or actually, sorry. The rearward, so if normally it's kicking this way, okay, that's your forward, and then when it comes back, it's pushing the air that's in that cabinet, I guess, the cabinet volume, and shoving it out that little port, and that is going to add some bass. Is that how it's working? So is the port meant to be the right length to create a phase? Because that seems like you're putting out of phase bass in. Or maybe not. Okay, so let's see. A reflex port is a distinctive feature of this popular enclosure type. The design approach enhances the reproduction of the lowest frequencies generated by the woofer or subwoofer. The port generally consists of one or more tubes or pipe mounts in the front baffle or the rear face of the enclosure, depending on the... okay, so if it was coming out the rear, you wouldn't be worried the same way about the phase. Okay. Depending on the exact relationship between driver parameters, the enclosure volume and filling, if any, and the tube cross-section and length, the efficiency can be substantially improved over the performance of a similarly sized sealed box enclosure. And, I'm wondering if I'm going to get a lot more bass out of my FR if I put in a ported enclosure, but I kind of don't want it. I'm pretty happy with the way it sounds. I stuck it in a Fender Mustang, and I got to tell you, except for the fact that the Mustang volume knob is garbage, although somebody sent me a schematic and I was able to get a little bit better idea. And so I ordered some pots. And we might fix it this week. So we'll see. Okay. Comparison with passive radiator. So I think this, it's saying this is making a Helmholtz resonator basically out of your speaker. But instead of stealing bass, this is going to add it. The frequency at which the box port system resonates, known as the Helmholtz resonance, depends upon the effective length and cross-sectional area of the duct, the internal volume of the enclosure, and the speed of sound in air. In the early years of ported speakers, speaker designers had to do extensive experimentation to determine the ideal diameter of the port and the length of the port tube or pipe. However, more recently, there are numerous tables and computer programs that can calculate for a given size of the cabinet how large the port should be and how long the tube should be. Even with these programs, some experiments... Well, okay. I don't understand, but you're just going for one frequency? That sounds wrong. It seems like this is like an EQ that's going to completely wreck your setup. Hold on. If this vent air mass box air springiness resonance is so chosen as to lie lower in frequency than the natural resonance frequency of the bass driver, an interesting phenomenon happens. The back wave of the bass driver sound emission is inverted in polarity for the frequency range between the two resonances. Since the back wave is already in the opposite polarity of the front wave, this inversion brings the two emissions in phase, although the vent emission is lagging by one wave period, and therefore they reinforce each other. This has the useful purpose of producing higher output for any given driver excursion compared to a closed box, or conversely, a similar output with the smaller excursion, which means less driver distortion. The penalty incurred for this reinforcement is time smearing. Is it just time smearing or frequency smearing? In essence, the vent resonant augments main driver output by imposing a resonant tail on it. For frequencies above the natural resonance of the driver, the reflex alignment has no influences. For frequencies below the vent resonance, polarity inversion is not accomplished and back wave cancellation occurs. Furthermore, the driver behaves as though suspended in free air as the box air springiness is absent at that frequency, right? I don't know that this is explaining it this well. Let's see. So there's some greater... Okay, limitations. I don't know about limitations. What about disadvantages? Seems like you're throwing a whack out EQ on this thing. Yeah, sorry the background. don't DMCA me Nancy Pelosi. I'm sorry. This band practicing. They're playing some covers. I think I don't think anybody's gonna die. Nobody's getting this stuff stolen. All right. Yeah. So that's Wikipedia's version of ported whatever. So related to this, I want to talk about and look at speaker impedance. So probably if you're a guitar player, much to your chagrin, you've come across an impedance mismatch where either a speaker was too low impedance or low ohms, 4 ohms, 8 ohms, 16 ohms, or whatever. It was unsafe for your amp because it's too low impedance, or it's not making enough power because it's too high impedance, or whatever. So I always wonder, why do you make different impedances of speakers anyways? Like, why wouldn't you just make them all 8 ohms or whatever? And so there's a couple of different pages here. I'm gonna look at this Jeff the Gray Geek. He says speaker impedance refers to the load of a speaker places on the amplifier. Uh-oh. Well, that is the effective speaker impedance. Technically, speaker impedance is the resistance of a speaker offers to the current supplied by an amplifier. Boy, this is not sounding good. The impedance isn't a fixed thing. This is the thing about speakers. Like, I don't know much about this stuff, but this is the part that I understand very well. Let me see if there's a picture of this. Okay, here we go. If you look, so this is a picture of a probably an 8 ohm speaker, right? Let me see what they're going to call this. Yeah, this one says it's an 8 ohm speaker. Okay, so there's a point in this where it's 8 ohms. The lowest it ever has is 8 ohms, or that's actually a little bit less at some super low frequency. They're calling this an 8 ohm speaker, okay? So you guys with all your purity, super flat, whatever, that's what you're looking at. I don't even know what, they don't really put very good demarcations on this, but I suppose that you see there's a spike low down, like 100 whatever hertz, especially if this is a guitar speaker. If you look at this, flip it over, and that's the curve if you ever look at a speaker simulator like an Impulse or whatever, look at the curve that it puts out, and it's going to look very similar to this curve upside down, except for this part will probably be flat across the top, because we're not boosting back in under 100 hertz or whatever normally. Sometimes you would. So this is Jensen. I don't know which Jensen this is. This is Jensen that makes guitar speakers? It could be. Builder profiles. Let's see. Okay, well, I think this is Jensen that makes the speakers, but not Jensen that makes the transformers. There's a lot of Jensens out there. Okay, so they say the speaker ohm rating is an indication of the speaker's AC impedance, which varies with the frequency of the input signal. This variation of the speaker's impedance can be seen on the speaker's spec sheet impedance curve. This is why the spec sheet indicates this speaker to have an 8 ohm nominal impedance. And you look at this thing, almost all of it is above 8 ohms, Okay, let's see what they say here. Most of the speakers are available in alternative ohm ratings, usually 4, 8, and 16 ohm versions. This variety allows for more flexibility in matching the overall equivalent impedance of your speakers to the output impedance of the amplifier. It is important that the output impedance of your amplifier matches the overall equivalent input impedance of your speakers for maximum power transfer, so that you do not damage the amplifier. So you can wire them in series or parallel, whatever. But it's not really a very good definition of impedance. Let's look at speaker impedance. Let's see somebody with a good one. I'm not sure I think Splice is that plug-in company. This is the problem. Where do we go for somebody you trust? Boy, not of these. See, this is scary. No, I don't want videos. Hold on. See, back in the day, Google was useful. Nowadays, it's completely useless, man. Um, let's go. Measure impedance. Learning about electronics, maybe. See, I trust this a little bit more than the speaker sites. Honestly, that's kind of sad to say, but it's true. Okay, learning about electronics says all speakers come with a rated impedance. Well, it's already untrue. Um, Speaker impedance is the amount of resistance that a speaker offers to the electrical current that flows through it. So I had a couple questions. Why do we use different impedances? Why aren't they just all 4 ohms or all 8 ohms or whatever? It'd sure be a lot easier to make the amps than that. And so if you use a speaker with a lower impedance than the amplifier drive, you might overheat the amplifier, and you can short circuit an amplifier. You think about, look at this impedance curve again. So imagine your power amp, your 2 wires. Sorry, let me turn the camera back on. Your 2 power amp wires, and they're here except for an 8 ohm resistor. That's not much resistance. 8 ohms is jack diddly, right? And so you better have a hefty one that can dissipate a lot of watts. And now you're talking like 2 ohm resistor or something. You may as well stick them together. Like, that's not much resistance, and it might even go below 2 ohms. So, like, look at this 8 ohm one. It seems to go down to a little bit below 8 ohms anyway. So that's how you cook these things. Okay, and then if you put too high of impedance on, it's a voltage divider, right? So you're not getting as much out of the amp as you could. And if you had like a 4x12, you probably wired them in series, parallel, or series or parallel. So here's put them in series. You put the positive to the positive of one speaker, the negative of that speaker to the positive of the next speaker, and you add the 2 resistances together directly, and that's your impedance there. That's, if you remember your electronic theory and stuff. If you put them in parallel, you're basically going to divide them in half. Or you're going to divide them by the number of speakers. So if you have, your 2 25-watt speakers, this isn't how I do it actually. You would end up with only 4 ohms, right? Or you use 2 16-ohm speakers, you end up with 8 ohms. And series parallel is how you usually see these 4x12. So if you do it in series parallel and they're all the same impedance, you end up with, at least on a 4x12, you end up with the same impedance as any one speaker, right? So, but why? Why have different impedances? And so, let's see if Jensen has anything to say. They're showing about the wiring, but what is the sound? They don't seem to say much about, or anything about, why you would have different impedances for sound. Let's see if somebody else has something to say about it. Most hi-fi amps is okay. So let's try this Google again. Why have? Hold on, let me answer this real quick. Sorry. Hello. All right, sorry about that. Some problem with the live stuff. I see one that says the truth about speaker impedance. I'm not sure who these guys are. They make speaker wire and cables, which scares me. Unless, because this is it's one of those ones where we always talk about, like, the crazy fake speaker wires, like $60,000 wires and premium oxygen-free straight wire music premium cable. Yeah, see, I'm not going to take any advice from these guys right here. Sorry. Here's Sweetwater, which is going to be hit or miss. And Sweetwater, I love you. I was bummed that you sent my stuff FedEx because that cost a really penny, and they missed their window like they always do. Anyways. Okay, so they're asking the same question as I do. Why do speakers have different impedances? Is there an audio reason for this? What they're saying, if all other things are equal, the only difference in speakers with different impedances is by definition the impedance. Not to be too glib about it, but in practice, that pretty well sums it up as well. There are numerous factors that go into speaker design that we really don't get into here to understand how things work in practice. Suffice to say that in modern designs, you may encounter a variety of impedances among loudspeakers that are otherwise nearly identical from an operational point of view. Further, once multiple speakers are combined in an enclosure with a crossover network, a new net impedance for the system will result. This is the load the amplifier sees, but it may not be the actual impedance of the raw components. Okay, that doesn't really help. Speakers with higher impedances will result in less current flow from the amplifier. While it is sometimes true that this can result in slightly less distortion in the amplifier. And why is that? Is this like one of those little feedback loops where you can, the higher impedance, it's going to be, keep things from ringing, keep oscillations under control? Why would that be? But that's interesting. It isn't always a major consideration. There are other issues such as damping factor that are also affected by the load, but those are all considerations that often take a back seat. But does damping factor depend on impedance? What you gain by having lower net impedance is more power output from the amplifier. Again, why don't we just have 2 ohm speakers, all of them? You might not find this to be a huge concern in the studio, but in sound reinforcement applications it is quite often the foremost concern. When outfitting a large PA system, you can cut the number of amplifiers you need nearly in half by working with the 4 ohm loads instead of 8 ohm loads. And when you're talking about dozens of amps, that can be a big cost savings. Okay, so we know about the power thing, the maximum. Here, in fact, let's just put this in here. Maximum power transfer theorem. Maximum power transfer theorem explains that to generate maximal external power through a finite internal resistance DC network, the resistance of the given load must be equal to the resistance of the available source. In other words, the resistance of the load must be the same as Thevenin's equivalent resistance, or the resistance of the load must be equivalent to the resistance of the circuit, right? And that's where we'd be. You got an 8 ohm amp, you got an 8 ohm speaker, and you get the most out of it that way. But is that true? Because if you got 4 ohms, you're going to get even more, right? I mean, this is confusing stuff. Okay. I know for a guitar player, like we're talking about right now with these FRFRs, I just ordered a Harley Benton, one of those little 100-watt pedal amps, and I just found out that it's 220 volts instead of 120 volts, so I had to buy a voltage adapter regulator to run the Euro power stuff on this, but hopefully there's a tap in there that I can just change it so I don't have to use that silly thing. But this thing will do 190 watts allegedly at 4 ohms and 100 watts at 8 ohms. I'd rather have the 190 watts, So it seems like the same amp will give you more power at a lower ohm load. So I don't know about that. How does maximum power transfer equate when you're talking about speakers and amps? Because no, it's not true. You're going to get more power out. Anyway, so as guitar players, you're always looking for more power out of your amps, right? You don't want to. You can carry half as many amps. That'd be nice. Or at a more practical level for most musicians, look at the following example. You have a bass amp and you need a good speaker for it. You can choose an 8 ohm 15-inch loudspeaker or a 4 ohm 15-inch loudspeaker. Your amp will produce, say, 250 watts into 8 ohms and 500 watts into 4 ohms. You may or may not decide to get the 4 ohm speaker to maximize the output of your amp. Or maybe you could get 2 8 ohm 15 inch speakers and wire them in parallel with another one to produce a 4 ohm load. Aside from those practical considerations, another reason it's more common to see speakers with lower impedance these days is because modern amplifiers are more capable of remaining stable while delivering large amounts of power into these loads. And there you go. Maybe it's not frequency, maybe it's not any of that stuff. Let's look at impedance versus stability. Let's see, is this oscillation they're talking about? See, these are talking about some big systems. How about speakers? Must include stability. Come on. AV Gadgets. What is AV Gadgets? I'm not sure what this is. They are an Amazon associate. That doesn't mean that they're bad. I tried to be one once. Let's find out. You know, I specifically said stability. I swear there's a stable. Yeah, where is this? Do I have to find the cached version of this? Cached. I swear it said the word stability on here. Where is it? That impedance switch on your receiver is a lie? No. So where was... Oh, maybe it's in a comment. No. That was helpful. Okay, so that's not helpful. Speaker stability versus impedance. See, we're learning at the same time here. Oh, how enjoyable that is. Speaker impedance versus sensitivity. Bob is the oil guy, okay. This is an automotive electrical. Hey, I'll trust the car electrical guys more than I'll trust one of these guys selling the $90 guitar cable, right? Impedance will vary. What are you talking? Oh, sensitivity, not sensitivity. Stability. Stability. Jeez. See, this is what I'm talking about. Google is pretty much worthless now. Speaker stability. Now, Sound on Sound used to be great. This is a 2013 forum post, so, well, let's see. Output of the amp to be 0. Let's see if I can find this stability word. Okay. No, that's not really helping. Yeah, so I've seen this in a couple places. I've seen oscillation, ringing, and stuff. That the more impedance you got, the easier it is to control that. And isn't that true in microphones? Like, that was one of the reasons, like, you know, you had all these big deal about these low-Z mic preamps and low-Z mic mods. And these are mostly the mics that, like, SM57s and whatever. They're not really meant to put out pristine 20 kilohertz signals, right? Yeah, see, these guys, I don't trust any of these. Embedded audio. Matching and tuning output, stability. Yeah, I guess this is this is one of those ones where there's, it's just hard to find information on. And it's something that a lot of people take as just gospel, that, you know, there's, that higher impedance speakers sound better. So I always hear it. Higher impedance speakers sound better. The higher impedance, higher damping factor, more stability. I just wonder if that's not true at all. You know, I'm not seeing any real good evidence for it. I can see how it'd be easier, but, you know, with the production techniques we have now, I should be able to get it pretty low. And we're seeing all these, like, super low power or low draw, let's say, like Class D amplifiers and stuff, and they're teeny weeny little things. Actually, I'm probably going to get a couple of them to try with different guitar cabinets and stuff because they're tiny. They don't weigh anything, but they're crazy loud, like my FR speaker I got out there. And they run into really low ohm loads. So the other one was headphones, because all these crazy problem you have with all these headphones, and these people just scream up and down that, oh yeah, you can't use low impedance headphones, or you can't use high impedance headphones. And so here's a site called Headphone Honesty, Headphonesty. The importance of matching headphones with audio sources in the pursuit of high fidelity audio. And you know, already when you talk about audio files, you're like, ooh, that's scary. But let's see what they have to say. Impedance matching. Why are some headphones high or low impedance? Let's check that first. Headphones with impedance greater than 100 ohms are typically older professional studio-specific designs. Pre-1990s receivers and pro audio equipment often use resistors to attenuate the speaker output to create simple and inexpensive headphone circuit. Yeah, you could run resistors in parallel with power amps and stack them that way, and then run each tap out to headphones. That was what do they call it, like the 70-volt system or something crazy like that. Or you could run a whole ton of them if they were super high impedance and not make much draw at all. Yeah, in fact, I was looking at that yesterday because we were actually testing the output of the Fender Mustang 3 V2 to see just how flat it was for powering that Celestion FR. And some of my direct boxes have amp taps on them, but they're meant to be run in parallel, and they have super duper crazy high impedance, so you're not really going to run power through them. So here's, again, this is very barely touching the surface. Without getting too heavily into the math behind it, the high impedance load preserves the source audio output, without getting too heavily into the math behind it, the high impedance load preserves the source output voltage to be able to drive multiple pairs of headphones. So yeah, there you go. If you have a super high impedance, you know, you could put a bunch of them on and the amp's not really going to see much difference. This idea was so prevalent that even as recently as 1996, the standard recommended source output resistance was 120 ohms, and went so far as to claim that source impedance had very little effect on performance. Stereophile said something. I don't know if I trust them. I think Ethan said that was actually a good magazine back in the day. Most modern headphones are designed to appeal to as wide a market as possible, and that means they must play well on mobile devices. The sale of hundreds of millions of battery-powered music players, including the ubiquitous iPod and more recently smartphones, have made the lower impedance around 32 ohms headphones the norm. Why? You're not saying why. Yeah, see, I watch on these, like the Helix forums, or at least the Gear page when they're talking about Helix, which headphones do I use? They all talk about the same headphones, but they're which version, which impedance do I use? A 32, 250, or 600, or, you know, whatever, 3280 or 250. And let's see what it does here. It's a square wave response. Do I care? Okay. So you're showing the biodynamic DT880 between the 32 ohm, 250 ohm, and 600 ohm. And it says, the above graphs show the square wave and impulse response of the three DT880 impedance headphones. Here you can see that the 32 ohm DT880 rings markedly more than the other two headphones. So again, less stability, so it's like oscillation or whatever. So what is it? Is this one hit of a square wave, and this is the post ring? Yeah, let's see. CNET says something. I didn't like this though, because CNET often uses weasel words. The impedance of a headphone is largely determined by the driver's voice coil, and for biodynamics high impedance models, the voice coil's wire is super thin, just 0.018 millimeters, half the thickness of a human hair. Biodynamics senior project, I explained. The thinner wires have more windings on the voice coil than the lower impedance biodynamic headphones, which have thicker and heavier, easier to manufacture voice coils. The lower moving mass of the 250 and 600 ohm headphones voice coils is lighter than the 32 ohm models, and the lower mass is part of the reason high impedance headphones sound better. Okay, so he's saying high impedance headphones sound better, but they're talking about different things. Okay, the voice coils have lower moving mass on the heavier, thicker and heavier ones. That makes little sense to me. I would think that if you're going to make, what are you making, some lighter drivers? Smaller diameter of the 600 ohm voice coil wires allows the wires to fit tighter. Okay, this is speaking backwards. Okay, hold on. Let's read this again. Thinner wires have more windings than the lower impedance headphones. Okay, so yeah, the higher impedance ones have much thinner windings. Okay. The smaller diameter of the 600 ohm voice coil wires allows the wires to fit tighter, so there's less air between the windings, and that makes the electromagnetic field of the voice coil stronger. All of that reduces distortion for the high impedance versions compared with the low impedance headphones. Okay, so why don't we run high impedance headphones for everything? If properly matched to the appropriate amplifier, it is possible to achieve an enhanced quality of sound with high impedance headphones, at least with specific designs like the biodynamic models shown above. Please don't take this to mean that excellent sounding low impedance headphones do not exist. This is just one company's approach. Okay. So they're talking about sensitivity, how sensitivity and impedance impact volume. Sensitivity and impedance are related but not causally linked. Both must be considered when pairing headphones and sources. It is tempting to describe impedance as simply being resistance. Use Ohm's law to calculate voltage equals current times resistance. But Ohm's law is really only applicable to direct current. If impedance was the same as resistance, comparing identical headphones that differ only in impedance would result in the higher impedance headphone always being quieter than the lower impedance one, given the same source voltage. However, it isn't always that simple. I thought it was. Let's see. It's easy to understand that sensitivity and volume are directly related. All else being equal, more sensitive headphones will be louder. Okay, well, this isn't really telling us much. It's enough to know that source impedance, headphone sensitivity, and headphone impedance are all factors that play into the resulting audio volume and performance. Okay. But we're showing that some drastically different impedances and sensitivities. Okay, frequency and impedance. Here we go. So, just like you saw on that speaker chart, there's going to be one peak of this stuff. Driver impedance is not linear with frequency for dynamic headphones. And so there's a peak. It's got more impedance in certain places. And, you got to think that in a guitar speaker, for damn sure, that means that at those certain places, you're not getting much of that frequency. And at other ones, you're getting too much, right? And it looks like that in this guy too. I'm just looking at the impedance curves. Forget the phase curve. So do you make your amplifier take that curve out, or you're sitting with the EQ of that headphone, just like you're sitting with the EQ of a speaker? So that's kind of sketchy. Anyway, so I was looking at Reddit, which probably bad to do, but there's a Reddit headphone thread, and says in the old days it was to allow multiple headphones to be plugged into an amp in the recording studio without having the headphone impedances drop to zero almost instantly. So you had like the super high impedance headphones back then, like we're talking earlier. It also says, I know there are reasons that high impedance coils make it easier to control the driver. And like we heard in the other one, that those thinner wires, you can put more of them closer together, easier to control. Anyway, that's my little journey into impedance. So one thing that gets discussed constantly, and I got taken to task for this for a long time, but there still isn't a DAW bench M1 test as far as I know. There is no Apple M1. You know, everybody talks about this Apple M1 chip is just so much better than the Intel chip, and it just blows it away and all this stuff. And every test I've actually seen, that's not true. It's for most of the part, it can't come close to hanging with the Intels that I've seen so far. But we've got native M1 stuff, and it seems to be running okay. As far as I know, you still use Windows if you want the lowest possible latency, the most plug-in count. And DawBench would be the people that tell me that, and I don't see anything from DawBench on the M1 yet. But they just, well, that's not true. So let me read what DawBench just said. Coming off of radio silence, this is from DawBench. The CPU wars are back with a vengeance, sparked by Apple's return to non-x86 chips. The resulting hysteria from some circles is, for me, reminiscent of the late 90s and early 2000s when there was the RISC versus CISC, PowerPC versus x86 battles from their respective camps. So I don't know if you remember, Apple used to use like Motorola chips or whatever, and then they came over to the superior Intel chips, or maybe there's even like some run on AMDs, like Hackintoshes or something. And then within the last few years, Apple is transitioning away from Intel into their own one, the M1s, which are, as far as I know, they're more like graphics chips, which sounds pretty interesting to me. And it sounds like a good idea. I just, usually with Apple, there's so much hype and most of it's just nonsense. And, you know, we've lived for decades where the Windows machines just smoke the apples, right? So, it's hard to believe, but I guess the M1s really are like that. So let's see. Back then, there were more than a few questionable RDF moments with superior performance claims that were not really panning out once the rubber hit the road. Yeah. And we are again seeing the same, if not higher level of hysteria surrounding the new Apple Silicon's performance superiority across articles, blogs, etc. You know, I heard about, like, it's supposed to be superior with the graphics. The graphics were horrible, man. I know there's some sort of thing that's supposed to be optimized for it. I'll check it out, but come on. Of course, my focus is purely audio production and DAW performance, things that are CPU bound as opposed to GPU bound, IPC, multiprocessing performance, etc. So after reading through and following up on some of the comparative performance tests posted and not getting anywhere near the variable being reported, I turned my attention to developing a suite of DawBench sessions that would run natively on cross-platform and across both x86 and the new Apple Silicon. So finally, we're going to get some DawBench results here. Sorry, 1 second. Let me see what's going on. I don't know if I have a... so, yeah, that should be fine. Yep. Okay. Sorry. I just had... my brother needed some time at the studio. The next hurdle was to find trusted testers that had access to the new Apple Silicon units. You should have called me. I got an M1. I have one of those MacBook Mini. It's a joke. It's 13 inches. Doesn't have any ports or anything. Total joke. Sans an emotional attachment that we... oh, okay. Yeah, he knows how much I hate apples. That we could add to the team to expand the testing pool. Testing is ongoing, and we already have a large collated database. Currently, we have taken a bit of a breather while enjoying some of the northern summer break, but we'll finish up the testing and post the results sometime in the next month or so. I won't give too much away just yet, but I will say that the results are not in line with some of the hysterical claims being made by some of the other commentators. Intel's 12th generation already has Apple's measure with less cores, and with new chips coming from both AMD and Intel in the next 6 months, including the new HEDT Xeon WS line with the higher core, the gloves are off. Stay tuned. P.S. I have my goggles, gloves, and biosuit on hand in preparation for when I release the reports. Sounds like the Apples probably aren't doing as anywhere near what people are claiming. Let's see some of the comments here. So Samlo, very interested. I've been running an M1 Mac Studio for a while now. I have the suspicions Rosetta is a contributor to while things aren't as blistering fast as they said it would be, as Pro Tools is still not native to M1. So a lot of things that are, say, M1 aren't actually for the M1 chip. They're for a translator program, would you call it that? Called Rosetta, that lets you run the older Intel coded stuff onto the M1 chips. Let's see, still a lot of variables, obviously, until everything goes 100% as native. But my testing is not through Rosetta. It's 100% native in Reaper. Again, Reaper rules. Sorry. Using internal plugins on the DSP testing and Contact 6, which is Apple Silicon native for the VI testing, virtual instrument testing. Apple Silicon is fast, don't get me wrong, but nowhere near as fast as being made out by the RDF pundits. I don't know what RDF is, sorry. Apple will need more than gains being made in M2 once the larger core next-gen AX80 SID hits. Interesting. Some people just can't handle what the hard data shows. This will be fun. I'm a PC guy and welcome Apple's innovations to market. It spawns fiercer competition. Yes. And that's the thing. I think this M1 really did scare Intel, which is good. So when do we picket Steinberg headquarters about MMCSS? Okay. We're not going to talk about that right now. I wonder if Apple is still a winner when it comes to power efficiency, though. What does that mean? I mean, if it can't run it, it's not going to be efficient, though. Anyways, so Dawbench is coming out with this thing, but there was a possibly. Sorry, let me check my monitors. Blue Cat, who I really like, is a really cool plugin company. We use on this show. We use the one of their frequency analyzers all the time. I was using it the other day. So he did a thing, Apple M1 versus Intel for audio, a benchmark. Yeah, new Apple M1s have been available for a few months now, and raw CPU performance is one thing, but what does it actually do? So he tests some stuff. One is an Apple M1 MacBook Pro, 16 gigs of RAM. This is really similar to mine. 4 high performance cores and 4 high efficiency cores. I think that's how mine is. An Intel i7 MacBook Pro with 32 gigs, 4 cores and hyper-threading. Okay, and they're one's running Big Sur, one's running Catalina. 44K with an RME. Okay, so we're running good. So those have native Apple M1 drivers. And again, that provides native Apple M1 drivers. You guys that say that there's no drivers on a Mac, you're wrong. The drivers are there. You may not download them, or you may in some cases, but they still use drivers. It's not like you get RME performance out of a Behringer when you plug it into a Mac. Okay. No third-party host applications nor plugin was used during this test, as we have been running Patchwork or Axiom as standalone applications are loaded as plugins inside of them. They both contain a variety of built-in effects with very different algorithms. Now, are these M1 native, though? Is Patchwork M1 native? But it actually, even if it's not, it was actually doing better. So, according to this, lowest latency without dropouts. The M1 got 2.7 milliseconds round-trip latency. I think that's round-trip. Maybe that's not. Maybe that's just the purported latency. And the Intel was at 3.2. They both had some pretty low CPU use, but they said you would hear crackles. And the Intel Mac, while the average CPU usage was still quite low, audio dropouts would occur at latencies lower than 3.2 milliseconds. I think that's a good sign. It could be something else, but I mean that's definitely a good sign that it's not longer, right? CPU performance at lowest possible latency, and average CPU and when they're running that lowest latency. Apple was getting 18%. In Rosetta, it was getting 29%, and the Intel one was 32%. So even Rosetta is faster. That's kind of interesting. And multi-core results are about the same. And interesting, you see that it uses more on the multi-core. We've kind of been telling you that, right? On anything, even the Intels. Even at a lower latency, the Apple M1 is faster than the Intel Mac, either in native mode or when running through the Rosetta translator. So that's good. But again, right now, who cares? Like, this is a big chunk of change right here, 32% compared to 18%. But with the kind of stuff people are saying, I mean, that's almost half the CPU use, which is great. So it's like doubly as powerful, but you kind of expect that in that many years anyway. here we come to max instances. And this is where, with the hype that was generating, you're talking, this is where it matters. This is when people say, okay, this thing is faster. You mean you can run a lot more instances of something. Okay? Max instances on M1 is 4 and Intel is 2. Big deal, but maybe this is the wrong thing to test with. I want to see something like the ReXComp test at DawBench. If you're running 1200 in the M1 and only 600 on the Intel, okay, we're talking, because that's a lot of different things that's got to happen right. But the way these guys are talking, be like 4 times as many or 8 times as many or something. Now they're going to put 128 samples latency and run the those CPU tests. So, okay, that was at the lowest latency, so that wasn't bad. Okay, so the max instances went from 5 to 13. That's substantial. It's not anywhere near the hype factory, but it's a lot. But again, it's kind of what you expect over time. Even if you said this was the old Intel and this is the new Intel, that's kind of what I'd be expecting to see, something like that. The average CPU, however, once we reach those latencies, you're really not seeing much difference there. 8.9 versus 13%. You could really move. But he's saying that M1 is much faster than the Intel Mac, I guess. So at 192 samples, so a little bit higher latency. Yeah, see, this is narrowing the gap. Interesting. M1 stayed cool. Yeah, I'm not surprised. I'm blown away by just how little power my M1 uses. But this is the first real test I've seen. I don't know this is exactly how I'd want to make the test, and I'm not seeing giant things. I'm kind of just seeing what I would expect to see based on the time that's passed. But at least we see something, and I love Blue Cat Audio. Let's because we're here, let's take a look around Blue Cat's site. So I like their measurement tools. What's the difference between home and bluecataudio.com? Let's see. That's their blog. Let's go to. So they make some really innovative stuff. I don't know what this remote control thing is, but where is it? They make some really cool. Where's it? Plugins, all software. I want to see the analysis. Yeah, here you go. Audio analysis. Yeah, frequency analysis, and then frequency analysis multi. Those are handy. They're almost like oscilloscopes, or they're good RTAs. Freak Analyst Pro has like a 3D waterfall thing, which is really cool. Oscilloscope multi. I wasn't really able to get that to do really much of oscilloscope functions that I wanted, but it's still neat. So go check them out. I got a lot of camera stuff to figure out and a lot of audio work to do this week. So I'll see you guys next week. Thanks for hanging in there, though. Whoever's on Twitch. See you later.